Only 40 participants are. What about others?
Next is for 2/3 in my
Sir, you are muted.
Okay, in the last class, as we were discussing about the types of polymerizations, okay, coming to the types of polymerizations, we have three types more. One is addition polymerization. Coming to the types of polymerizations, we have three types more. One is addition polymerization, what is condensation, and co-polymerization. We need to discuss one by one with examples. We are coming to the first one, what actually this addition polymerization is. Yeah, coming to the addition polymerization or chain polymerization. Okay, here a chain polymerization is the reaction that involves the polymer product, which is the exact multiples of monomers. How many the monomers are present in the polymer? Also, the same number of monomers are there in the polymer. Okay, thus the mechanism called as addition. Okay, chain polymerization is the reaction that yields a polymer which is the exact multiple. Same polymerization of monomers, exact multiples of monomers. Okay, this is called as addition polymerization. Addition polymerization. The functionality of the monomer is the double bond and it is a bifunctional. Okay, the functionality I will tell you what is the functionality of monomer. Is a double bond and it is a bifunctional. Here in the example, if you take in the addition polymerization, here ethylene is a monomer. Okay, here ethylene double CH double bond CH2. Okay, ethylene. The functionality of the monomer is double bond. Okay, it is a double bond. Here it is in the ethylene, it is having the double bond and it is a bifunctional, means the number of bonding sites in the monomer. Functionality means number of bonding. There are two bonds. Okay, two bonds are present in the monomer. Okay, this is the functionality is nothing but number of bonding sites. Number of bonding sites that are present in the monomer is nothing but functionality of the monomer. Here, in this addition polymerization takes place by self-addition. Okay, self-addition of the monomer molecules to each other through chain reaction. Okay, the self-addition of monomers takes place each other through the chain reaction. Here, there is no byproducts like H2O and CH3OH. It's nothing but methyl alcohol are produced. Okay, there is no byproducts are formed in the polymerization. Okay, simply it says that the voice is stuck in. Okay. Okay. Here, no byproducts like water, H2O, and methyl alcohol, etc. are produced of the polymer is the multiples of the monomer. Okay, the exact multiples. How many monomers are present? Okay, that much amount. Okay, how much amount of okay molecular weight is present for the monomers is the same as the molecular weight of the polymer. Yes, who is it? A2. Here, no byproducts like H2O, methyl alcohol, etc. are produced in the addition polymerization, and the molecular weight of the polymer is exact multiple, exactly same as the molecular weight of the monomer. That is the molecular weight of the polymer is exact multiple of molecular weight of the monomer. And here polymer has the same chemical composition. Okay, there is no different chemical composition. The polymer, like if you take the example of ethylene and the polyethylene, it is having the same molecular composition, means same formula. Okay, here N in the presence of polymerization, ethylene, I'm writing over here. Okay, H2C double bond CH2 N. Okay, N indicates the number of monomers. On polymerization, these on polymerization gives polyethylene CH2 single bond CH2. Okay, here N, it like we are representing N after this means it indicates the polymer chain. Polymer chain. Okay, monomers on polymerization gives the polymers. It is the same. There is no change in the chemical composition. Okay, same like monomer only. Okay, CH2 double bond CH2 on polymerization, it produces CH2 number of chains. Okay, this is the same chemical composition as that of monomer. The polymer is having the same chemical composition as that of monomer, and here the conversion of pi bond to sigma bond. The monomer, this is the monomer, this is the polymer. Okay, ethylene is the monomer and the polyethylene is the polymer. Here pi bond, the conversion of pi bond to sigma bond takes place during the polymerization. Here CH2 double bond CH2, here it is having the pi bond is present. Okay, this is converted into sigma bond in the polymer. Okay, it liberates during the conversion of monomer to polymer. Conversion of pi bond to sigma bond takes place during the polymerization, and it liberates 20 kilocalories per mole of energy. Okay, during this conversion of the sigma bond to pi bond to sigma bond, it liberates the 20 kilocalories of per mole of energy. Hence, it is a highly exothermic reaction. Highly exothermic reaction. Okay, this is the addition polymerization or chain polymerization. Okay, here the chain polymerization is the nothing but the polymer product which is exact multiples of monomers. So we call it as addition polymerization. Here the functionality of the monomer is a double bond. Double bond means number of bonding sites present in the monomer is nothing but functionality of the monomer. Okay, here it takes place by the self addition of monomer. Self addition of monomer to each other through the chain reaction. There is no byproducts are produced in the addition polymerization. No byproducts like H2O, CH3OH, etc. produced during the this process, chain polymerization. Here molecular weight of the polymer is exactly same as that of monomer. Okay, exactly same as that of monomer. Here the chemical composition is also the same as that of monomer. And during the conversion of pi bond to sigma bond, what happening here during the conversion of pi bond to sigma bond, it liberates an energy that is 20 kilocalories per mole of energy is liberating, and it is highly exothermic reaction. Highly exothermic reaction. These are the key points of the addition polymerization. Okay, functionality of the monomer is a double bond and it is a bifunctional, and there is no byproducts are produced during this reaction, and it takes place by the self addition of monomer molecules, okay, through the chain reaction. So it is called chain polymerization. It is a self addition. Here the molecular weight of the polymer is the same as that of the monomer, and the chemical composition as that of monomer. During the conversion of pi bond to sigma bond, it liberates an energy that is 20 kilocalories per mole of energy is liberating, and it is highly exothermic reaction. Okay, the exact opposite to the this is polymerization. Okay, here the opposite is the
That
condensation.
voice break is
Condensation.
in
Okay, okay. Wait a minute. Now coming to the examples of this addition polymerization or chain polymerization. Here, examples we are taking is polyethylene, PVC, polyvinyl chloride, and polystyrene. Coming to the first example of the addition polymerization or chain polymerization on polymerization. Okay, in the presence of heat and pressure as a catalyst. Okay, heat in the presence of heating this monomer ethylene, it produces the polyethylene. Okay, this is the polymer. Monomer is ethylene. We are taking the polyethylene is the polymer, and the vinyl chloride. How we are going to get this vinyl chloride is a monomer. This in the presence of a catalyst. Okay, under pressure, heat under pressure, it produces the PVC, polyvinyl chloride. PVC. This is a commonly called as PVC, the polymer, polyvinyl chloride. This is the vinyl chloride. The formula for the vinyl chloride is uh, on the ethylene. Okay, if you remove the CH2 is the ethylene. If you remove the hydrogens and replace the one hydrogen with Cl, that is nothing but vinyl chloride. Vinyl chloride is the formula for vinyl chloride is CH uh, Cl double bond CH Cl is the formula for the vinyl chloride. Vinyl chloride in the presence of catalyst, heat under pressure, it produces the polyvinyl chloride is a polymer. Okay, these are the examples. Styrene, the formula for the styrene is on the benzene, if CH double bond CH2 is present, that is called as a styrene. This styrene in the presence of initiator, okay, it produces the polystyrene. These are the examples for the addition polymerization or chain polymerization. Here there are no byproducts. Okay, see, there are no byproducts like H2O, CH3OH, etc. are produced in this product, and it takes place by the self addition. Self addition is nothing but here on self addition of this ethylene itself undergoing the addition, it forms the polyethylene. There is no other compound is involved in this. Okay, self addition of monomer molecules each other to produce a reaction. and no byproducts like H2O, and whatever the molecular weight of this polymer is, exact multiple of monomer. Okay, it is the same as that of monomer, and the chemical composition is as that of monomer. The polymer is having the same chemical composition as that of monomer, and the conversion of pi bond to sigma bond takes place. Here it is we are converting this in the monomer we have the ethylene. Ethylene is nothing but H2C double bond CH2. This is here sigma bond gets converted into pi bond gets converted into the sigma bond. It releases the energy. Okay, the liberated energy is 20 kilocalories per mole of energy is liberating. So it is highly exothermic reaction. Examples are polyethylene, polyvinyl chloride, and polystyrene are examples for the addition polymerization or chain polymerization. Okay, this is a mechanism. Now coming to the condensation polymerization. Yeah, this is also called as step polymerization. Condensation or step polymerization takes place by condensation of reactions of functional groups of monomers with the elimination of byproduct. Okay, so just the opposite to the addition polymerization. Here condensation, step polymerization takes place by the condensation of functional groups of monomers. There are two monomers are involved in the condensation polymerization with the elimination of byproduct. See, in the example, we are taking adipic acid and hexamethylene diamine. These are the monomers. Here, by the elimination of byproduct like H2O, here H2O is eliminating. Example for this is a nylon 6,6. Nylon 6,6 we called it as here condensation of adipic acid plus hexamethylene diamine. Okay, by eliminating H2O as a water molecule, it produces nylon 6,6. This is the byproduct H2O. We got it here. Here adipic acid, formula for adipic acid is C double bond O. Okay, C double bond O, CH2 taken 4 times. Okay, and C double bond O, OH. This is the monomer, that is adipic acid. Adipic acid reacts with hexamethylene diamine. Okay, hexamine 6 methylene. Okay, 6 methylene diamine. NH H2N plus CH2 taken 6 times. Hexamethylene diamine in the presence of adipic acid. It produces, reacts with adipic acid, produces nylon 6,6 with elimination of H2O molecule. This is the preparation, preparation of nylon 6,6. Here the monomers like functional groups like OH. Here monomers having the functional groups. Adipic acid is having the OH functional group. Okay, and the hexamethylene is also the monomer here. Okay, it is also contains NH2 functional group. Okay, the monomers contain the functional group like OH, COOH, NH2, halides, etc. The monomers contain the functional groups like OH, alcohol, acid, amine, halide, etc. Okay, here the functionality. Okay, functionality of the monomer is number of the, what is the functionality of the monomer? Functionality is number of bonding sites present in the monomer is nothing but functionality of the monomer. Here functionality of the monomer must be 2 or more than 2. Functionality of the monomer is 2 or more than 2. The monomer must be dibasic and diamines. Okay, here it should be contain 2 NH2 groups or 2 acid groups, like 2 acids, like in the adipic acid it is containing 2 acid groups, COOH groups. Okay, COOH here CH2 taken 4 times and COOH. Okay, it is nothing but it contains 2 acidic groups, dibasic acid, or in the hexamethylene diamine it contains 2 amine groups. The meaning of this, the monomer must be dibasic acids or diamines, etc. Okay, here on polymerization, it accompanied, okay, in the polymerization reaction is accompanied by elimination of byproduct. Okay, in the addition of this adipic acid with hexamethylene diamine, it is eliminating the byproduct. 2H2O is eliminating. Okay, elimination of byproduct like HCl, methyl alcohol, H2O, etc. takes place. Okay, here this is not the exothermic reaction. Okay, it is quite opposite. Here the conversion of sigma bond to pi bond to sigma bond, it liberates energy, that is 20 kilocalories per mole of energy is liberating. But here there is no conversion of sigma bond to pi bond takes place in the condensation polymerization. So it is not the exothermic reaction. Reactions are not exothermic, and the molecular weight of the polymer is not the sum of the molecular weight of the monomers. Okay, the molecular weight of monomer is different and the polymer is the different in the condensation polymerization or step polymerization. Condensation polymerization or step polymerization. Okay, here there is elimination of byproducts like H2O, HCl takes place. Hence it is called condensation polymerization. Here we are condensing the two molecules, two monomers, by the elimination of H2O produces the polymer. Example we are taking that is nylon 66. Okay, here the monomers in the preparation of nylon 666, 66 is adipic acid and hexamethylene diamine. Hexamethylene diamine, it produces what nylon 66. Here the monomer it contains two, it must be dibasic acids or diamine groups. Diamine groups, these are the points. Monomer contain the functional groups like OH, COOH, NH2, halides, etc. And the functionality of the monomer must be 2 or more than 2. Okay, it is nothing but number of bonding sites present in the monomer is nothing but functionality of the monomer. Here it should contain 2. 2 is or more than 2. It is having the two functional groups. Okay, here COOH and COOH and NH2, NH2 are the present in the uh, uh, where in the hexamethylene diamine monomer and adipic acid. So the functionality of monomer is more than 2 or 2. Okay, then only it undergoes a condensation polymerization. Monomer must be dibasic and diamine. In the it is accompanied by elimination. Okay, here the elimination of byproducts like HCl, methyl alcohol, H2 are taking place, and there is it is not the exothermic reaction. Exothermic is reaction, it is not the exothermic, means it is here we are not converting any, the conversion of pi bond to sigma bond takes place in the reaction by liberating the energy. So it is a non-exothermic reaction, and the molecular weights are different for the monomer and the polymer. Okay, molecular weight of polymer is not the sum of the monomer. Okay, there in the addition polymerization or chain polymerization, the molecular weight of the monomer is exactly the molecular weight of the polymer, but here it is different. Okay, and the example for this is we are taking the preparation of nylon 66 adipic acid is hexamethylene diamine gives the nylon 66 with elimination of H2O as a byproduct. H2O as a byproduct. Okay, here nylon 66, this is the, okay, we are going to prepare threads, woolen threads. All these are prepared by the using this nylon 66 use. Okay, polymer. Okay, co-polymerization is nothing but giant polymerization of two or more monomer species. Co-polymerization is the joint polymerization of two or more monomer species. Two or more monomer species. Here, high molecular weight compounds obtained by co-polymerization. High molecular weight compounds are obtained by co-polymerization. We are taking the examples. Okay, here we are taking the example of preparation of butyric rubber. In the core polymerization is the nothing but polymerization of two or more monomers, more than two. Okay, here whatever the product we obtain in the preparation, okay, In the synthesis of these copolymers are high molecular weight compounds. By copolymerization or copolymers, we are taking the preparation of bunized rubber. In the bunized rubber, we are taking the monomers, that is 1,3 butadiene. 1,3 butadiene. Butadiene is nothing but butane. Butane is the formula for butane is 4 carbons. Compound is nothing but butane. Okay, 1,3 butadiene. CH2, CH, single bond CH, double bond CH2. It reacts with, okay, styrene. It is not this one, okay, styrene. On the benzene ring, CH2O, CH double bond CH2. This is nothing but styrene. 1,3 butadiene reacts with styrene in the presence of, okay, sodium metal, okay, heating, okay, heating. It produces on polymerization. It produces what? Butadiene or butadiene styrene copolymer. We call it as, okay, we call it as bunized. Bunized. Why means sodium is the metal involved in this. So okay, butadiene plus styrene, bunized rubber. We call it as GRS rubber. Okay, butane plus sodium metal in the presence of styrene produces bunized rubber. We call it as bunized rubber or butadiene styrene copolymer. Here the product we will get is CH2. Okay, CH2 single bond CH, double bond CH, CH2, CH2, CH. Okay, here on this we're taking the styrene ring. Okay, it's a polymer. It's a polymer. On monomer, monomer involved in the preparation of okay, bunized rubber is 1,3 butadiene plus styrene produces bunized rubber. Bunized rubber is the preparation of is prepared by the monomers 1,3 butadiene and styrene. In the presence of sodium metal heating, it produces the bunized rubber. Bunized rubber or styrene butadiene styrene copolymer. Bunized rubber. Yeah. Now coming to the this what is the use of this bunized rubber is, it is prepared by using this. We are going to prepare the shoes. Whatever the rubber that is obtained by yield of this is used in the preparation of, okay, the manufacturing of shoes. Okay. Coming to the differences, what are the differences between addition and condensation polymerization? Okay, addition is nothing but addition we call it as differences between addition polymerization and condensation polymerization. Yeah, coming to the what actually the addition polymerization or chain polymerization, condensation or step polymerization. In the addition polymerization, monomers must have at least one multiple bond, means it contains the double bond. Okay, multiple bonds are nothing but in the CH2 double bond, CH2 and CH triple bond, acetylene, ethylene, acetylene. The monomers, these are the monomers. It should contain one multiple bond, means it should contain double bond, is nothing but multiple bonds. Here, the monomers must have at least two identical or different functional groups. See, in the preparation of nylon 6,6, okay, the monomers is having the what we are taking, adipic acid. Adipic acid is having the C double bond OH and CH2 taken 4 times and COOH. Okay, it is containing two identical functional groups. The monomers is having the at least two identical or different functional group. And in the this is monomer. This is in the presence of this in the presence of wait a minute. Okay, sorry. Yeah, in the addition polymerization or the chain polymerization, it should contain at least one multiple bond. Sorry. But in the condensation polymerization, the two functional must be identical or different functional groups. Identical or different functional groups. The monomers must be contain at least two identical or different functional groups. Here monomers add on give polymer and no byproducts are formed. Okay, already you know this. Okay, what are the differences here is there is no byproducts are formed in the addition polymerization. Already taken the example ethylene. Okay, monomer is the ethylene. On polymerization, it produces a polyethylene. Polyethylene. There are no byproducts are involved in no byproducts are formed in this. Okay, here it produces the byproducts like what H2O. H2O that in the preparation of nylon 66 we got the byproduct is H2O. Okay, the monomers involved in this preparation is adipic acid, react with hexamethylene diamine CH2 poly with elimination of what H2O molecule. H from the NH2. Okay, 2H2O takes place. Means nothing but byproduct is eliminated. Okay, monomers condensed to give the polymer by products such as a polymer and a byproduct such as H2O, methyl alcohol, etc. are formed. A number of monomer units decreases steadily throughout the reaction. Okay, number of monomers are monomeric units decreases steadily throughout the during the as on polymerization. What happens? Number of monomers present is gone decreases, but in this initial itself, LD stage of reaction only the monomers are disappearing. Okay, here at the steady means starting it is constantly it appears, but later on it decreases. But here at the initial, the first stage itself, monomer is disappearing. We are taking adipic acid and nylons, this hexamethylene diamine. These monomers are not appearing in the product, that is nylon 66. Okay, monomers disappear at the early stage of reaction only. It means there is no monomers in the polymer. The polymer is different, whatever the monomers we are taking. Now coming to the molecular weight of the polymer is an integral multiple of molecular weight of the monomers. Means how much amount of monomers we are taking, that much amount of the polymers are obtained in the addition polymerization. But here it is not like that. Okay, molecular weight of the polymer is need not be the same as that of monomer. Okay, integral multiples of monomer need not be the same that of monomers. Here high molecular weight polymers are formed at once. Okay, high molecular weight polymers are formed at the end of the reaction. Here, molecular weights of the polymer rises steadily throughout the reaction. Okay, throughout the reaction, molecular weight of the polymer raises. Here, long chain. Okay, longer reaction time gives higher yield. Okay, during the preparation of polymer, if the more amount of time is required, long reaction time gives the high yield of the product, but have the little effect on molecular weight. Okay, it has a little effect on the molecular weight of the monomer. Here, longer reaction time are essential to obtain high molecular weight of the polymer. Okay, here longer reaction time takes. Okay, as a more amount of reaction time is required to obtain the high molecular weight product. By using this thermoplastic resins, okay, thermoplastics are produced by addition polymerization. Addition polymerization, thermoplastic resins are produced. Thermoplastics are produced. Thermosetting plastics are produced by condensation or step polymerization. Example: polyethylene, PVC, polyvinyl chloride, okay, polystyrene. All these are examples for the addition polymerization or chain polymerization. Thermosetting plastics are produced, okay, by using this condensation polymerization. Thermosetting plastics or thermosetting resins are produced by condensation polymerization. Example: bakelite, urea formaldehyde, okay, phenol formaldehyde, nothing bakelite. Here urea formaldehyde is no different like monomers and polymers. Homo chain polymers are obtained. Here heterochain polymer. Hetero means different. Different chain polymers are obtained in the condensation polymerization. Different chain polymers are obtained by this condensation polymerization or step polymerization. Okay, differences between addition polymerization and condensation polymerization. Okay, addition and condensation polymerization. Okay, the exam they may ask what are the differences between addition polymerization and condensation polymerization or chain polymerization, step polymerization. Addition we call it as chain polymerization, and condensation is the step polymerization. Okay, these are the differences. If you have any doubt, you can ask. You can ask okay, chain polymerization is nothing but here the reaction that yields the polymer product, which is the exact multiples of monomer. Okay, exact how many monomers the polymer obtained is the same as that of monomers, nothing but exact multiples of monomers. Here the functionality of the double bond and is a bifunction. During this process, the separation of monomer takes place. Okay, each other through the chain reaction. There are no byproducts are obtained. No byproducts are formed in the addition polymerization. And molecular weight of the polymer is exact multiples of monomer. And here the same chemical composition takes place during the entire reaction, and it is a exothermic reaction. Exothermic means during the conversion of pi bond to sigma bond, it releases the liberating the energy, that is 20 kilocalories of energy, calories per mole of energy is released during the conversion of pi bond to sigma bond. So it is, we call it as exothermic reaction. Exothermic reaction. Examples for the addition polymerization is polyethylene, polyvinyl chloride, polystyrene, etc. Okay, here ethylene by we are going to prepare the polyethylene by yeah, you can ask my doubts. Any doubts in the addition, condensation, and co-polymerization? These differences are important. What are the differences between the addition polymerization and condensation polymerization? Okay, condensation example, taking the preparation of nylon 66. Okay, example for the condensation polymerization, we are taking preparation of nylon 6,6. Here the monomers we are taking involved in the preparation of nylon 6,6 is adipic acid. Okay, hexamethylene diamine. Okay, here adipic acid by the elimination of H2O water molecule produces the nylon 6,6. And the co-polymerization is the polymerization. Giant polymers are involved in which two or more monomer species high molecular weight compounds are obtained by co-polymerization or called copolymers. Example, butadiene and styrene copolymerize to yield GRS rubber. Okay, that is bunais rubber. Butadiene in the presence of sodium and styrene, nothing but bunais rubber. Yeah, is that? Yeah, if you have any doubts, you can ask me. Addition, condensation, and copolymerization. The differences between the addition polymerization and condensation polymerization. Here monomers have the at least one multiple bond. Multiple bond is nothing but double bonds. Okay. Ethylene we have CH2 double bond CH2 and acetylene. And in this condensation, we have at least two or more identical functional groups. Like in example, we are taking the adipic acid. Okay, two COOH groups are present. That is nothing but identical functional groups. And the monomers add on to give polymer and no other byproducts. Here there is no byproducts are formed in this reaction, addition polymerization. But in the condensation polymerization, the byproducts like H2O, methyl alcohol, etc. are produced. Okay, are formed. Number of monomer increases. Okay, as number of monomers unit decreases steadily throughout the reaction. Okay, throughout the reactions, the number of units of monomers has been decreased in the addition polymerization. But here in the early stages itself, monomers are disappearing. Like we are taking the monomer like adipic acid and hexamethylene diamine. These two monomers are not obtained in the, okay, these same monomers are not obtained in the polymer, that is nylon 66. That is the meaning of monomer disappear at the early stage of reaction. And the polymer, okay, the molecular weight of the polymer is same as that of molecular weight of monomer in the addition polymerization, but it is not the same as the molecular weight of monomer in the condensation polymerization. Here, high molecular weight monomers are polymers are obtained at the once, but here it is throughout the reaction we will get the molecular weights. Longer reaction time gives a higher yield in the addition polymerization, but here it is obtained by longer reaction times are essential to obtain high molecular weight. Thermoplastics are produced by this addition polymerization, and thermosetting plastics are produced by the condensation polymerization. Homo chain polymers is obtained. Here the same polymers, homo means same chain polymers are obtained, different chain, okay, different. By using this adipic acid and hexamethyldiamine, you will get the nylon 6,6, that is different one. Okay, that is nothing but hetero chain polymer is obtained. Okay, this is about addition, condensation, and co-polymerization. Okay, the next class we'll discuss about the plastics. Okay, yeah, if you have any doubts, you can ask. I'm stop sharing the screen.
Sir,
Yeah, tell me.
sir, the CIE pattern, could you let us know?
Yeah, like it is. We don't know how the exams are conducting. Like it will be on offline or online. Okay. If
Okay.
it is online, the paper pattern is different. That is the reason. Okay, we don't know.
Sir,
Like
how about you let us
any
know about
other you will came to know. You will get that in the telegram. Whatever the pattern
okay,
is.
sir.
Okay. Like other faculty has informed discussed about this paper pattern. Like
No, sir, no, sir.
no, that is a dilemma we have. We don't know how the pattern will be. Okay.
Okay, sir. Thank you.
Okay. Thank you.